welcome in everyone to our 50th STEM Wednesday. We realized that this was kind of a milestone number, so we're going to do things a little bit differently today. We're going to have a few more fun and creative holiday ideas. Of course, things related to STEM, 3D printing, scientific measurement, as you're used to hearing from us. But also, we're going to have a little bit of fun with the holiday theme. Jonathan is going to present some holiday baking ideas, at least the beginnings of baking, because he's not going to have too much time to go through all of it. But he's going to use the Labdisc for that one. And then I'm going to talk a little bit about once you're done baking, or at least further in the process, 3D printing some holiday cookie cutters, if that's something you'd like to try with your students or at home. And so that is the content for today. But then the real fun part comes at the end where we're going to be giving away some gifts. We have a whole bunch of giveaways for you, and we're going to do a random drawing. So stick around, and you might have a chance to take home an excellent prize today. And with that, Jonathan, I'll turn it over to you. I'm going to stop my screen share here, and we'll get started. So take it away, and I will see you guys in about 10 minutes when we switch back over to me.
Awesome. Thank you, Evan. Well, I wanted to do something a little holiday themed today. So we're going to do a little bit of kitchen chemistry, and this is really applicable to any grade level. And it's really some simple things you can do. You don't need really any fancy measurement tools. Some of the stuff can be done with just a simple thermometer. But it shows a lot of the science that happens behind what we do when we're baking or cooking in the kitchen. So I'm going to change my camera view here. So you can see what I have set up. So you're seeing from my perspective as I see things here, but everything should look correct on your screen as if you were standing behind the counter in my place here. So we're going to talk about a couple of different things. The very first one is when we're baking bread. The most important part of baking bread, or at least most breads, and there are a few that don't use it, is yeast. In bread, yeast is the primary ingredient that gives that bread the light and airy texture that we'd like. And that's because yeast actually metabolizes the sugar that we add to the bread as we're making it. And in that process, it releases CO2. And when it releases that CO2, that's how we get those bubbles that form in the dough. So this first experiment I wanted to show here, I'm going to be using my Labdisc. So I have my Labdisc here. My Labdisc is an all-in-one science lab. It has multiple types of sensors built into it. This one is specifically the Biochem Labdisc because it has all the sensors I'm going to use for today. And I'm going to be starting off by just using the thermometer. The thermometer is this little external probe piece here. And what I have set up here in these three beakers in front of me is going to be a concentration, different concentrations of yeast and sugar. In the process where the yeast breaks down the sugars, it actually generates heat during that process, or that chemical reaction that happens. And depending on what type of bread you're making, sometimes the recipes call for different amounts of yeast. And that changes how that bread turns out. It might be more airy, it might be a little bit more of a dense bread. So what I have here in my largest beaker is a same amount of yeast, but we have the most sugar in this one. We have in the middle one a little bit of sugar. And then in the small one on the right-hand side here, my right-hand side, is going to be no sugar, just yeast. So I am actually using my iPad as well here so we can see my difference in measurements. So it's just measuring temperature. So on my y-axis here, that's temperature. Along the x-axis, we have time. And as I let yeast sort of work away at this sugar, like I said, it generates heat. And I'm going to place that probe into each of these beakers. And because I'm doing this in a small quantity, the change I'm going to see is very minimal. I actually started each of these maybe 5 minutes or so before we started here today. But what we should notice is the more sugar that we have, the more yeast that we have, the bigger difference in temperature that we're going to have. And so I went to the middle one. We had a slight drop in temperature, which is to be expected. I went to the smallest one here. The temperature should drop even more. And it's just barely happening. I don't know if you can even see the difference on your screen there. But if we expanded this to maybe we're making an entire loaf of bread, we could take and pop that probe right into the dough and measure the heat generated by the yeast in each of the doughs as we're baking. So I'll let that one continue to run there. And then I'm going to move over to the other piece that I have here. So here on the hot plate, I have just a beaker filled with water. And I'm using a different sensor now. Inside here, I have a conductivity probe. So I know there's a sort of big urban myth, maybe I've heard, that when you are making pasta, a lot of people like to salt the water in the pasta, and they think that the um, salt added to the water changes the boiling point of the water, makes it boil faster, maybe. And this is true. And that's because salt actually lowers the melting point or the freezing point of water. So I'm going to switch over here. I'm going to be measuring conductivity now. And the reason why I'm measuring conductivity is because the addition of salt to water is actually going to make the water conductive. The more salt I add, the more I should see the conductivity increase. I'm going to start my recording here. I'll pause here quick before I do this and I'll answer a couple questions in the chat. So before I test each, I would definitely ask for predictions. If I was doing this with students, I would have them predict which of these is going to generate the most heat, the least amount of heat, and maybe even have them give an explanation as to why. And then the second question I see is, what app am I using for the data? So this app is called Globulab. It's the app that accompanies the Labdisc. So it's actually Bluetooth connected from the Labdisc to my iPad here that you're seeing to display that data. Globulab is available on really all devices, and depending on which device you're using, Chromebook, Mac, Windows device, it's going to look slightly different from device to device. Okay, so right now we have that conductivity probe in there, and we see I have a flat line right now, conductivity. And I'm going to take and I'm going to add just some table salt here. And I could do this in set amounts, but maybe I'll ask you before I add this table salt, what do we expect to see with that conductivity? Oops, I splashed just a little bit in. Maybe I ruined the surprise here. I'll go ahead and do it since I ruined the surprise. And so as we add salt, we should see that conductivity start to rapidly increase. And the more salt I add to that water, more conductive it's going to get. And so there's some different variables here I could test. One of these variables I could do, or I could work with, is heat versus how quickly that salt dissolves. Right, I can tell that the salt is fully dissolved in the water because my line becomes stable again. It stops increasing and it becomes stable again. So if I adjusted the heat and maybe I heated this water up a little bit, pardon me, if I heated that water up a little bit, I might see that that line or that increase happens in a shorter or longer amount of time, depending on the effect that heat might have on it. If I can go ahead and I should be able to add some more salt. We should see hopefully another spike here. And I'm not being super scientific about this, but I could take and measure set amounts of salt and try to relate the addition of salt to the rate at which my conductivity increases there. And we're getting this bouncing up and down because I believe that after 3000, we've reached the limit of conductivity measurement for this specific probe, which is why it's starting to really get upset. Either that, or I might have gotten some solid salt directly into the probe itself, which we don't necessarily want. And this is something that we could do with all different types of salt. So I saw a question in the chat. We could look at table salt. We could look at sea salt. We could look at Epsom salt. Right? There's many different types of salts we could use, and we could do that exact same experiment and compare the different types of salt. A similar experiment to this deals with oil. I didn't have this one set up because I think my wife would be very upset if I made a mess of oil all over the kitchen. Um, but with oil, we could actually do a similar thing where we heat the oil for a set amount of time at a set temperature, and we look at the specific heat capacity of oil. So different oils, if we're familiar with cooking, use different oils in different types of cooking. And that's because different oils have different, they call it a smoke point with oil, but it's the temperature where they go from being heated up to essentially burning. And different oils have the ability to absorb different amounts of heat. So you could compare um, olive oil to vegetable oil to grapeseed oil. Right, there's tons of oils that are used in different types of cooking and for different purposes in cooking. So there's just a couple examples of how we might use our Labdisc in the kitchen in the next couple of weeks here while you're doing some of your holiday meal prep. I've even used my Labdisc to measure temperature of a turkey before, and you can pop that right in your turkey and measure turkey temperature if you wanted to, I guess. But I think I'm going to turn it over to Evan now, and he's going to sort of talk about uh, a different way to go about doing some things with cooking and baking in the kitchen.
Thank you, Jonathan. I really wish I had thought to use my lab disc on Thanksgiving because our meat thermometer definitely broke and we were just guessing on that turkey. Luckily, it turned out okay, but I'm going to have to keep that handy for next time because that is a really fun idea. Thanks for sharing the conductivity probe. That's a really cool idea. Uses tons of common ingredients that obviously most of you should be able to access pretty quickly. We did have a question in the chat about can you print out the data from your iPad? I don't think most iPads are connected to printers. They certainly will print if there's a network printer involved that is on the same network that's compatible with the iPad. But the best thing probably for that case is to export your data from the iPad. It will export it as a CSV file that can be opened in Excel, and then you can print it from that. You could also, of course, take a picture of that graph if you'd prefer to just print that graph, but probably easier to print from another device that's connected to the printer. Exactly. Um, you can you can actually export it or just take a screenshot, whatever works for you and your students. All right, so let's do a quick pivot here and talk about, in association with those STEM concepts, also a little bit of creativity and student expression. And so there is a whole other side of MimioSTEM that's related to 3D printing. So I thought I would show you some options there. If any of you have access to a 3D printer, whether that's one from us or anyone else, these tips should work pretty much the same. But a really fun activity to do around the holiday times with your students is to let them either choose or design their own 3D cookie cutters. And then if you're able to actually put those into practice, if you have the facilities in your school, or the students can take them home and use them to bake at home. And so I have a couple ideas here for how you might implement that. The first one is for those people who are just getting started with 3D printing or those classes where maybe you don't have time to fully design your own cookie cutter, which is totally fine. We are all especially busy right around the time before holiday break, and so no need to overwhelm anybody with that. But we've got some collections here for you. I'm going to put this link right in the chat here. This is a link to a website called Cults 3D, which is pretty good at providing high quality 3D models. And so this is a collection of cookie cutters. You can see many of them, although not all, are holiday themed. So we've got gingerbread men, reindeer, snowmen, holiday socks and candy canes, Christmas trees, etc. And all you would need to do for something like this is to click into the page here for that particular 3D model. Let's hope that loads up. There we go. And then all you need to do is download your STL. So in this case, I'm just going to go ahead and download it here. You may need to sign up for an account. And also, one thing that you want to make sure that you're looking at for Cults 3D is free. I'm assuming that none of you really are
Hey,
particularly
Evan,
interested.
I don't see that you're sharing your screen. Is kind of
Oh,
my
thank you, Jonathan. I
view
think I
here.
forgot to reshare. Thank you so much. All right, here we go. So here is what I've been seeing the whole time. Thanks for stepping in there, Jonathan. So the cookie cutter here, I'm highlighting that this particular model is free. You can see that here on my screen off to the right. Now, that is not necessarily the case for everything on Cults 3D. Some models are paid, and so you probably want to avoid those at least at first as you're exploring 3D modeling and printing. If you would prefer to go with a solution that is 100% free, then there's another website that I can share with you here. If I switch over here to Thingiverse, Thingiverse is 100% free. These models are very similar. In some cases, they're exactly the same. And so you should be able to see free models here as well. So I just dropped that link in the chat for you, and I'm going to go ahead and show you how to download one of these. So in order to get this model, you click in here and you can just click download all files, and it's going to just do a quick countdown, show you some ads, show you the license. Most of these are free to use however you'd like. And then it's going to give you a zip file. We can open that up, and if we click into it, there is your holiday sock cookie cutter. Of course, I'm using the RoboPrint program here because I downloaded a file. You can also use RoboCloud, which is our cloud-based printing software. And of course, you'd probably want to adjust this model a little bit, maybe rotate it so it sits flat on the platform, flip it down instead of printing standing up. Now, that's how we get a model from someone else. But there is a way to create your own. If you're up for it with your students, there is absolutely a really free and easy way to use 3D modeling with your students, and that is called Tinkercad. Tinkercad is a free platform. It's web-based, so anybody from any device can access it. We use it all the time here at Mimeo STEM. And I've gone ahead and created the bones here of a 3D printed cookie cutter for a Christmas tree. And so if I zoom in, you can see what I did here in order to create this was I used the shapes off to the right side of my screen, and I used the triangle, the triangular prism there. I adjusted the size of it. I actually copied and pasted it several times. You can see I made it bigger each time to create that tree shape. Then I did the same with a cube. And then in order to make it hollow, what I did was I took a identical shape, so another triangle here. I made it a little bit smaller, and I put it right inside my existing solid shape. So now I have a hole inside my shape. And if I use the group command here to group them together, you will see now I have a hollow shape, perfect for a cookie cutter. Now, of course, I still have a bunch of material in the middle here that I don't really need for a cookie cutter. I want to get rid of all of that and just have the outline. And so there's a few steps that we should do to make that happen. So I'm going to actually select all of my shapes here, and I'm going to use the align command up here. If anybody has worked with Tinkercad before, this is just a way to get everything all in a line. I'm going to make a vertical line here because, of course, it's going to be a tree. That shape makes a little bit more sense. And then I'm just going to select this top shape, use my arrows on my keyboard to move it down a little bit so it fits more in line with my tree. So you can see I have the beginnings of that shape here. Now I'm going to select everything one more time, and I'm going to ungroup the shapes so I see all the holes and all the solid shapes that I've built, and regroup them all together. So instead of individual shapes, now they're all one big shape. You can see I've got a thin surface with a space in the middle, perfect for cutting out some cookies. Now, of course, this probably needs a little bit more polish to make sure that the edges are thin enough to properly cut the dough. Probably want to get rid of this little bar here. But we're well on our way to creating our own cookie cutter. And that is something, since it's just designing one triangular shape and then repeating it over and over, and then making sure it all lines up and grouped together, that's something you can probably do in 1 or 2 class periods with your students if they've used 3D stuff before, or even perhaps if they're brand new to it. So if anybody's interested, of course, this website is tinkercad.com. So I'm going to put that in our chat. And I would encourage any of you to go check this out. This is a really fun platform, and students love just messing around with all of the great tools here. Now, when it's time to print our tree, you saw before I downloaded a file that's called an STL file. You can certainly do that as well. You can also go with this export button, just go up to the 3D print and choose Robo here, and it will send it directly to our RoboCloud platform to connect to one of our printers if that's what you have. You may notice some other options here if you have one of those other brands as well. It works with pretty much anything out there. So hopefully you and your students can have a nice time making some holiday themed cookie cutters or another holiday print. Ornaments are another great thing that you can do, just decorations for around the house, really simple stuff that you can get in Tinkercad or again on some of those other websites like Thingiverse. So that's what we've got for you here. Thanks so much for coming to our 50th STEM Wednesday. I don't know if you've had a chance to check out the previous ones, but we have a whole bunch on our Mimeo STEM YouTube site if you'd like to see some of our previous sessions. And then we are actually taking this opportunity for our 50th session to change our delivery a little bit. We are going to be moving to monthly sessions, and we are going to have more multiple host sessions just like this today where we can all chat together. And so next month on January 23rd, we have our next session. Anyone is interested in attending that, I'm going to paste our link for the Zoom sign up right here. Should be pretty quick to get to that one. And we will see you hopefully in January. I'm just going to stop my screen share so I can get that link to you. And thanks again, everyone. I really appreciate you spending some time with us today.
Thanks, everybody.